Alrighty, we are making a battery. So today I'm just going to show you guys how to construct the battery, what you're going to need, and we will explain why this is working later. So you're really only going to need a couple things. You need a couple pieces of cardboard like that, just about the size of a penny, and you need as many pieces of cardboard as you have pennies. And you need a couple of pennies, and the one thing you need to be sure of is these pennies need to be 1982 or before, because in that time period pennies were made completely of copper. Now they have a coating of zinc. Or no, now they are made of zinc. And then you're going to need some aluminum foil and some water, or some lemon juice diluted with water. So what you're going to want to do is simply get the cardboard and put it in the lemon juice. Get them all in there. Make sure they're fully soaked. While that's happening, what we're trying to do is we're making a stack. So for this, the purposes of it, for this video, I'm just going to make a stack of 5. But the more pennies you have, the higher the stack is, the more conductivity. So for this, I'm only going to do 5 because I'm not actually testing it. I'm just showing you how to do it. And so we'll just start now. Here's a penny. You're going to take a penny, put it down. Next up comes a piece of cardboard. That is 2. 1 piece of cardboard. And put a little folded piece of aluminum foil on. Repeat. You're just gonna do this over and over. You know, for our lab, I believe we did this about 8 times. But you know, I'm just gonna show you a smaller stack. Here's our finished product. We made this battery out of simply pennies, aluminum foil, and some cardboard. Stacked it up. You have to make sure the stack is in the correct order, which is pennies on the bottom, followed by cardboard, followed by the foil, and this is all it takes to make your battery.
Alright. 10 samples. Does that look good, do you think? Or wait a minute. No, I'm just going to make sure that we are setting it up properly.
Is that ours? Yay!
Mr. Grocer.
That song is
do some
so
flashing
great.
lights or something.
Wait, let me find the right spot.
Mr. Grocer, we have a new winner. Mr. Grocer, we have a new winner.
Sure, let's just go with that.
Okay. Are we done?
Well, let's. You got that? Alright.
Yep.
Alright.
Here is a diagram of the circuit that we use to test our penny battery. Here are the 8 cells of our penny battery. Electricity flows from here over to this switch, which splits the single wire into 2 separate different paths, each of which has its own electrical component. If we tested both of these components in our video. If the switch is flipped this way, the electricity then goes to this, the LED, which lights up, and in our video it's shown lighting up. If we have the switch flipped this way, it would go to the loudspeaker, which we also demonstrated in our video. We demonstrated that our battery was able to power the loudspeaker. Electricity then flows back into the wire and goes back to the other end of the battery, completing the current circuit.
Alright, here are our half reactions. Now, copper 3 holds onto its atoms more strongly than aluminum does, making the copper 3 pennies more negative than the strips of aluminum foil. This makes electrons flow from the copper to the aluminum. Eventually, when these forces are balanced, the copper pennies end up with more electrons than the aluminum strips, and the aluminum does not have the strength to get them back, making it positively charged. Now here we can see that the copper 3 is being reduced since it is gaining electrons, and the aluminum is being oxidized since it's losing electrons. The lemon juice, also known as citric acid, serves as the electrolyte and reacts with the two metals called the electrodes by causing the metal to either become oxidized or reduced. This process creates an uneven buildup of electrons on one side of the battery. Now once the sides of the battery are connected, the electrons flow in a current in order to balance up this buildup, resulting in an electric charge.
These are the theoretical voltage calculations for a battery. Because our battery used pennies from before 1982 and aluminum foil, we did the calculations for copper, which is what pennies from before 1982 are made out of, and aluminum from the aluminum foil. The way you calculate the theoretical voltage is by taking the standard reduction potential for the metal that's gaining electrons or being reduced, and you subtract the standard reduction potential from the metal that is losing electrons, being oxidized. Here, copper has a standard reduction potential of 0.34, while aluminum has a standard reduction potential of negative 1.6. So you do 0.34 minus negative 1.6, which gives you a theoretical voltage of 2.00 volts.